All right, so welcome to multiplying and dividing rational expressions. So if you haven't yet, you might want to practice your factoring because a lot of factoring is going to be involved in this. And I'm going to use shortcuts when I can just to make things go by a little faster. But please go back and watch the factoring review video if you need help factoring. It's going to be one of those things where if you can't factor, you can't do these problems. So you have to make sure that you can factor. So remember, there's always tutoring, there's always line time. Just send me a message on Remind or let me know in class to add you to the list, and I'd be happy to accommodate you, okay? So a rational expression, quotient of two polynomials. It's basically a polynomial dividing by another polynomial, so it looks like a fraction. Some examples, just throwing some out there. You know, these are all rational expressions. They're very simple looking rational expressions. We get to some more complicated ones, but that's basically what it is. It's a polynomial on top and a polynomial on bottom, rational expression. So we're going to be simplifying those. We're going to be multiplying those. We're going to divide them. We're going to add, subtract them. Not all in this video, but we'll do a little bit at a time. But let's see what we got. Let's see if we can get it to go. So first thing I want to talk about is basically undefined expressions or excluded values, if you want to think of them like that. Basically, values that don't really exist for or can't exist for the function. And the reason for it is because we can't have the denominator equal 0. Because remember, in fractions and math, you can never divide by 0. It blows things up. It just creates utter chaos. So for the first few examples, we're basically just going to figure out, we're going to simplify them, but at the same time, we're going to figure out the excluded values that they have as well. So for A, for this first example, let's first point out the denominator is 2x to the fourth. Now, remember, it's an excluded value, any x value that makes the denominator equal 0. So you can take your denominator and set it equal to 0. Now, this is a very simple one. And you solve it. When you solve it, you have x to the fourth equals 0 divided by 2, which is 0. And then you take the fourth root, but the fourth root of 0 is still 0. So x equals 0. I think that goes without saying. If you plug in 0 for x there, it'll turn the entire denominator into 0. So that is an excluded value. X cannot be 0 in this particular problem, because if it were, then it would make the denominator 0, and that wouldn't work. So as far as an excluded value goes, excluded value would be x equal to 0. Can't have that. Or really, we should say x cannot equal 0, right? It's probably how we should write it. But now let's actually simplify it. So when it comes to simplifying, again, this is a very easy or basic problem. Look at the numbers, 3 over 2, and notice, we can't really reduce that. 3 over 2 stays 3 over 2. There's not a number that I can divide both of those by, so we'll leave it as that. As far as x's go, there are 7 x's on top and 4 x's on bottom. So the 4 x's on bottom will cancel with 4 of the x's on the top. Meaning, if you take 4 out from the top, you'll have 3 x's remaining at the top, so x to the third. So if you want a visual representation of what that is, imagine you have 7 x's in the numerator, 4 x's in the denominator. Well, these 4 x's in the bottom cancel there, cancel there, cancel there, cancel there, leaving you with nothing else to cancel but 3 extra x's up on top. So in total, we have 3x to the thirds over 2x. So let's look at something a little bit more, I guess, higher speed, right? A little bit more our alley. So here, we're going to have to factor. So we're going to have to factor both the numerator and denominator. Because both of these, they're trinomials. Now, to remind you, and I'm going to say this again and again, you can't cancel things out in polynomials unless it's in its factored form. So, like, for instance, you can't just say, hey, look, x squared and x squared, those cancel out, yada, yada, yada. It doesn't work that way. If you have a whole polynomial here, all of those minus and plus signs are gluing every one of those terms together. So I can't cross one of them out because they belong to the other terms. So if you're going to cancel anything out, it would have to be the entire thing. It can't be a part of it. So unless you factor it, of course. When you factor it, you tear it apart and you can cancel those things out. So do not, under any circumstance, try to cancel things out like that. It won't work. That's just not how these problems are designed. So let's factor the numerator. Let's factor the denominator. So I'm going to do a little factoring off to the side. So for the numerator, I've got x squared minus 2x minus 3. Now to factor this, because it's a trinomial, I'll use product and sum. So a times c, that's 1, because it's 1x squared, times negative 3. So that's negative 3. And then b is negative 2. So my goal is to figure out what two numbers multiply to make negative 3 and add to make negative 2. So in this case, I believe it would be negative 3 and positive 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. And since a is 1, because it's 1x squared, that means that these are my direct factors, x minus 3 and x plus 1. X minus 3 because it's negative 3, and x plus 1 because it's positive 1. So that's my numerator. My numerator is x minus 3 and x plus 1. Now it's time to do the denominator. So I'm going to use the space to make my denominator, or to factor my denominator. So my denominator is x squared plus 5x plus 4. So again, 1 times 4 is 4, and b is 5. So I'm looking for two numbers that multiply to 4 and add to 5. Obviously, it's not 2 times 2. It must be 4 times 1. 4 times 1 and 4 plus 1 work here. So again, since a is 1 because it's 1x squared, I know that these are my direct factors. X plus 4 is one of the factors, and x plus 1 is the other. And that's my denominator. X plus 4 and x plus 1. All right, so make sure you can factor, because you can't do these problems, obviously, if you can't factor. But now let's talk about what we need to do. We don't really have a lot of hard work left, but there are two excluded values, because look at my denominator, and I have x plus 4 in the denominator. So I have to figure out what values would make that equal 0, because if that's 0, then the whole denominator is 0. So if you subtract 4, you see that x equals negative 4. So that is an excluded value. If you use negative 4 for x, then you're going to make the denominator turn to 0. And remember, we can't have the denominator turn to 0. So negative 4 is one of those excluded values. Again, we probably should say it doesn't equal. And the other one comes from the x plus 1 factor. It's in the denominator. So x plus 1 equal to 0. Obviously, you subtract 1 on both sides. You're going to see that x cannot equal negative 1. If it does, it would create a 0 in the denominator. So x equals negative 1 is our other excluded value. All right. So those are the excluded values. That is important. And you have to determine them before you do anything else in the problem, because now to simplify this, we cancel out what we can cancel out. So notice on top, there's an x plus 1, and on the bottom, there's an x plus 1. Now I can cancel both of them out because they're exactly the same factor, right? They're in their own little parentheses. They cancel out because they're the exact same thing. So the x plus 1s cancel out completely, leaving me with x minus 3 on top and x plus 4 on bottom. All right, and that is your simplified version. Now you cannot cancel anything else out here, because remember, you cannot cancel these x's because that x belongs with the minus 3 and this x belongs with the plus 4. If you were going to cancel anything else out, they'd have to be the exact same binomial. X minus 3 is only going to cancel if there's another x minus 3 it cancels with. Same thing with the x plus 4. X plus 4 is only going to cancel if there's another x plus 4. And obviously there isn't, so that's as good as it gets. Now, here's one thing else I want to point out. Notice, since the x plus 1 canceled out, it's still obvious that here you still can't have x equal to negative 4. But what about x equal to 1 or negative 1? Does that still work for this? Technically, it does work for this. However, as regarding the original polynomial, it wouldn't work. So that's why we have to find the excluded values first, because once we cancel things out, at this point in time in my solution, I wouldn't know that -1 was an excluded value because I canceled it out. It disappeared. So it's one of those things. You make sure you do the excluded values before you cancel anything out, because everything down there was the original sort of denominator. So that's the one that matters the most, is the original denominator. Now, this is still the exact same thing as this. If you graph this and this, they will look the same. However, there's a slight difference at -1 because of that. So just be mindful, okay? Let's just do, I guess, this bottom one here, just real quick. I'll probably end the video there, so I don't make it too long, and I can do multiplying, dividing in another video. All right, but our last one, do the exact same thing that we just did in B. So again, nothing here is going to cancel because all of this is tied together. The whole numerator is tied together, the whole denominator is tied together. So you have to factor each part first. So let's factor the numerator first. So the numerator, 6x squared plus 7x plus 2. Again, I'm going to use product and sum. So I'm looking for two numbers. A times C would be 6 times 2, so that's 12. And B is 7. So I'm looking for two numbers that multiply to 12 and add to 7. And those would be 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. Now, unfortunately, since A is not 1, A is 6, I have to use the long method. So what that means is I have to use 3x and 4x as x terms, or 3 and 4 as x terms to replace that original x term. So I'll keep the 6x squared. I keep the plus 2 at the end. But in the middle, I'm not going to write 7x. Instead, I'm going to write these two numbers that I just found in the puzzle, 3x and 4x. Together, they make 7x, so it's the same thing. But I need to use them to finish my factoring. So I factor by grouping. And so each group, I look for a GCF. So my first group, both terms are divisible by 3. Both terms have an x. So I'm going to factor out 3x. That leaves me with a 2x plus 1. And in the second group, I can factor out a 2. So bring that 2 out. That leaves me with another 2x plus 1. So my factors, I have 2x plus 1, because that's the common factor here. And then 3x plus 2, because that's the outside part. So 2x plus 1 and 3x plus 2. So that is my numerator. So got a lot of stuff to erase here. So my numerator, 2x plus 1 and 3x plus 2. 2x plus 1 and 3x plus 2. Now we need to factor the denominator. We're going to do the exact same thing to factor the denominator. So denominator is 6x squared minus 5x minus 6. So A times C, 6 times -6 is -36. And B is -5. So I'm looking for two numbers that multiply to make -36 and add to make -5. And in this case, it would be -9 and a +4. -9 times 4 is -36, and -9 plus 4 is -5. So again, because A is 6 here, not 1, I have to do that long method. So I keep the first term. I'm going to use the -9x and the +4x to replace that 5x. And then don't forget the -6 at the end. So again, it's just the middle term that changes. The middle term opens up to make with those two terms. So factor by grouping. Again, the GCF, my first group, they're both divisible by 3. They both have an x, so I'm going to factor 3x out. That leaves me with a 2x minus 3. And my second group, I can factor a 2 out because they're both divisible by 2. And that leaves me with another 2x minus 3. So the factors here would be 3x plus 2, because that is the outside part. And then 2x minus 3, because that is the inside part. So we have 3x plus 2 and 2x minus 3. So a lot of the hard work with these problems is simply factoring. So if you haven't gotten good at factoring yet, you really need to find a way to get really good at that. So before we cancel things out and simplify this, I want to find the excluded value. So the excluded values, again, look at your denominator and set it equal to 0 to figure out those numbers. So I've got 3x plus 2 in my denominator. So if I set it equal to 0, I'll figure out where the x value is that I can't have. So 3x equal to negative 2, divide by 3. So x can't equal negative 2/3. So x can equal negative 2/3. That's one excluded value. And then the other is 2x minus 3. So 2x minus 3 equal to 0. And let's figure out what the excluded value is there. So adding 3 to both sides, get 2x equal to 3. Dividing by 2, we have x equal to 3/2. So that's the other one. X cannot equal 3/2 either. So those are the two excluded values because those are the two factors in the denominator. And those x values would make the denominator 0. So those are the excluded values. Back to our problem, we can cancel out 3x plus 2 because there's 3x plus 2 on top and on bottom. So those both cancel out, leaving me with a 2x plus 1 on top and a 2x minus 3 at the bottom. And again, they don't cancel. There's nothing that cancels here because 2x plus 1 is all grouped together. And the only way it cancels is if there's another 2x plus 1 as well. I don't have any other 2x plus 1s, so it stays there. Same thing with the 2x minus 3. It's very tempting to say, oh, look, 2x's, those cancel, but they don't. They don't because, again, the plus sign attaches it with the 1. The minus sign attaches it with the 3. So those things are attached. So to cancel them, they have to be canceled out as a group, as a whole entity, which is like the 3x plus 2s. 3x plus 2 and 3x plus 2 are the exact same group, the exact same entity, so they can cancel out. But 2x plus 1 and 2x minus 3 are not. So that's our final simplified answer. These are the excluded values. I'm going to leave that there. I'll do multiplying in the next video. Now, good thing is multiplying and dividing are the exact same thing. And if you can basically do what we just did, then you can do multiplying and dividing. Multiplying and dividing is the exact same thing as simplifying. So spend most of the time on this video if you need to practice, but I will do multiplying and dividing in the next one. So I'll see you there.